Hello and welcome to lesson 4.4. Again, hopefully you're not jumping into this lesson without having a good understanding of lessons 4.1, 2, and 3. If you are, having difficulties with that, or if you're having difficulties with this lesson, I'd highly recommend looking over some of the previous lessons. Again, I I understand that it's difficult. Even like the videos, maybe I'm not explaining things properly enough, or maybe you don't understand the way I'm explaining it. Obviously, Mr. Tremoli has posted links to videos that he wants you to take a look at. Those are not exactly these lessons, but they're talking about similar concepts. But the idea, hopefully, I know some of you have reached out to me on Snapchat, and again, I just put that up there just so that I was thinking about it, and I think that's the easiest way for you to like ask me questions almost like we are face to face, and for me to easily give you answer explanations instead of worrying about email or like comments and typing and things like that. If you just take a picture, it should be easy, and hopefully we're keeping on top of the work. So yeah, just the idea is you're hopefully you're free enough to if you have a question while doing the work and you're like unsure of what's going on, or if you're like, oh, how is this part, even if it's like a small question, the idea is you can just easily contact me so that we can talk about it and clarify whatever your question's about. Of course, you can always post your question on the hub. Mr. Tremoli's has a link there with the questions, and obviously those are not only like test related questions, those are also math related questions which you can ask, or you can post a link, or not post a link, but you can put your question at the bottom of this video. I check comments on all my videos regularly, so I will be replying to that. But again, I just find that asking questions over a comment or text is slightly more difficult than asking questions on a picture where you just put like a question mark. But okay, I've rambled for 2 minutes already. Here we're gonna, again, there's not many questions as you can see from this worksheet. The main questions are obviously going to come from the homework. I'm going to give that a check out first. Let's see, 236. Yeah, realistically, you're gonna have to do these homework questions. We'll be going over them briefly, but we'll first take care of these lessons. And essentially, okay, there's nothing new that we're gonna be doing here. We're just gonna apply the same rules, except instead of like a number, it's gonna be like an x. So division rule: 2 minus 4 over 3, which is actually 6 over 3 minus 4 over 3, which is there we go. 6 over 3 minus 4 over 3, which is 2 over 3. And that's my answer. So this just saves you the trouble of actually evaluating some stuff. Here we have this weird looking expression. So first, you can do this multiple ways. I'm actually going to apply this negative 2 over 3 to both this 27 and the y. So this is 27 to the power of negative 2 over 3. And y to the power of 9 to the power of negative 2 over 3. This I'm going to then convert. I'm going to move 27 to the denominator, make it a positive power. This is actually y to the power of 9 times 2 over 3. I can do some cross canceling, which is y to the power of negative 6. And again, this is actually cube root of 27 squared times, and again, move the y to the denominator, make it a positive power. Here, cube root of 27 is 3, 3 squared is 9. That's my answer. So again, just working through it step by step, have a clear idea of what rules you're using. Please don't get confused between the rules. I know that's easier said than done, obviously, but it's what the key here being, of course, like anything, key here being good practice with so that you get quicker and quicker at doing these things. That's the basic idea. So, okay, let's take a look at some of these questions. I'm going to first, this is again, the idea here is you're taking negative a squared to the power of 4, which is a to the power of 8, b to the power of 4, and 16 to the power of half. So that's the square root of 16, so that's 4. A to the power of 4 times half is a to the power of 2 divided by b to the power of half. Again, I'm just basically multiplying everything, so I can just combine this as 4. A to the power of 8 plus 2 is 10. B to the power of 4 minus half, which is, 3.5 or 7 over 2. And that's my simplified answer. Again, I'm going to change this radical into a divided by 3, so 12 over 3 is 4. That was super easy. Again, just applying the rules with the caveat that there's now fractions everywhere. Times 4 divided by, again, this. So this actually, what I'm going to do is I'm going to make this 1 over 25 y to the 8 and change that to a positive half. Again, different ways of doing it. You can move the negative half and make this 25 to the negative half and y to the negative 4, but again, you'll get the same thing in the end. Here, 3 over 4 times 4, I can just cross cancel. This just becomes y to the power of 3 divided by 1 over, now 25 to the power of half is 5, y to the power of 8 to the power of half is y to the power of 4, which is actually y cubed times 5y 4, which is 5y to the 7. And yeah, that's, again, hopefully you're seeing that, I'm doing it, and I feel like I'm doing it, and like it makes sense to me, but like I'm going too fast, and it's like confusing. But hopefully we're following along with what we're doing. Just applying different rules. You can do it really in any order you'd like. It's not going to make too much of a difference. You get the same answer. But again, the proper application of rules here is very important. Again, let's take a look at this. I am technically multiplying everything here. There's no plus or minus sign. So I can just freely bring stuff to the numerator and denominator. But before that, actually, I'm going to leave this negative 2 for the time being and kind of simplify this mess here, which is negative 3 to the power of negative 1 is just positive 3. So now this entire thing has a negative exponent. It's in the numerator. I'm going to bring it to the denominator. There's nothing else in the numerator, so I have to put a 1 up there. This still is the whole squared, and then I have a 2x cubed here. This is 9x squared times 2x cubed, which is 1 over 18x to the power of 5. And that's my final answer. Again, it's going to get a lot complicated the next lesson, but we'll cross that bridge when we have to. For now, we're going to just take a quick peek at the homework and see if there's any challenging questions that you might need help with. Obviously, I'm not going to do all of them. That take too long. I'm just going to look at some of the ones that, well, basically it's all of this page. I see some interesting looking application questions with our favorite cylinder. Our favorite cylinder, our favorite, figure there. So we'll take a look at some of these questions. I don't think that these, again, this is just simple rules. Do like product rule, then like division rule, product rule. This is power 1, just add everything up. Product rule, add product rule, then do division, product rule, 1 minus 5 plus 9 in the denominator, then bring all of that upstairs. So like this is b to the power of negative 14 divided by b to the power of 5, which is b to the power of negative 19. Okay, you can try both these different methods and to evaluate. So again, the idea is simplification first, making this x to the power of 2 y to the power of 2 and then putting in these values is obviously much more easier than putting -2 and 3 into all of these things and then calculating it, because that's going to take, again, the idea is that you're using exponent laws to make it much easier to calculate these things. Okay, simplify, express answers with positive exponents. So here, first things first, I'm going to, again, you can think about this in different ways, right? Here I have a base with a negative exponent. I can move that entire base to the denominator and make the exponent positive. And in this case, it disappears, which is nice. And in the numerator, I'm still left with p cubed, q cubed. And now this is just a quotient rule. Again, here I'm going to have to flip the fraction with the positive power, y squared over x to the 6. Again, base here being in the numerator with the negative exponent, I'm going to move that base to the denominator. So 1 over a squared b to the 7 is what I have over here. Sorry. Here again, just move this 2 inside both of these terms, then just division. Yeah, this is also just use the power rule here and here, and just do division. You can just do the division rule. Obviously, if you do get a negative answer, I'm trying to look and see if there's any negative answers. You will have to change that to make it look positive. Here, because I have a negative, negative, and a negative, I'm going to get rid of all the negatives essentially by just multiplying stuff. Oh, except for this one. Okay, so be very careful here. We have to look at where the powers are and what we're doing. So here, this -2 applies to this. So -2 times -1 is going to be ab to the power of +2. But then this -2 applies to this a and this b because they're not in brackets, right? So it applies to both of them. So I have to do -4 and then here's +6. And this is going to, again, after this is just a quotient rule. I have a squared, b squared, a to the -4, b to the 6. Which in this case is a to the 6, b to the -4, which is a to the 6 divided by moving the b to the denominator and making that a positive. So here's where like our moving numerator denominator rule is going to come in very handy. Okay, these are the beast ones. Not really. There's beastier ones, I guess. Yeah, this is where it's going to start getting, complicated looking from here. Obviously, we know that it's not that complicated, but it's going to get complicated looking. So again, this is easy. You just 3 squared x squared y to the 8 times 2 cubed x to the 6 y cubed, and then just add powers. This is again easy. 4a to the 6 divided by that. Here again, everything is multiplied, so technically this 10x can just go in the denominator. I still have a y cubed in the numerator, which is this guy. Also in the denominator happens to be a 15 x cubed. But my y to the power -3, I'm going to actually move to the numerator because I don't want a negative power. So that makes it y to the power +3. Then I just add here. Add in the denominator. This is 150 x to the power of 4. And there's nothing more I want to do. Again, I don't want to really move the x to the 4 up top because, again, the goal here is to express answers with positive exponents. So whatever we can do to make the exponents positive, we are going to do that. There was different ways where you could have done that question, obviously. I'm not saying that my way is the only correct way. But it's just the way I find to be easiest. Here again, I'm just going to do 9 m to the 8 n to the 4 divided by 12 m to the -2 n to the 6. And now again, 9 and this is 3 in the numerator, 4 in the denominator. I'm going to use division rule in both cases. m to the 10, n to the negative 2, and now this n to the negative 2 I'm going to bring to the bottom as n squared. Okay, let's take a look at the harder ones. Erase this. I don't even know what question that is. It's probably from the previous thing. So again, here I have p to the negative 5, r to the 6 divided by p to the power of 4 r squared p to the power of negative 2. So here I have p to the power of negative 5 minus 4 plus 2, because I'm doing negative of negative 2. I also have r to the power of 6 minus 2. So that leaves me with p to the power of negative 7, r to the power of 4. I'm going to move the p to the power of negative 7 to the denominator so that I get a positive 7. Okay, what I'm going to do is look at this question. I have some big thing here, and then I have a negative 1. And I know negative 1, essentially what I'm doing is just flipping the fractions. I'm going to calculate all of this first, and then I'm just going to flip the fraction there. So this becomes x to the power of negative 3. Actually, you know what? I'm going to do it the other way. I'm not going to open that up. I'm just going to move this entire thing to the denominator and make it a positive. This entire thing to the denominator, make a power positive. So x cubed y, now the power is positive 1, so I'm just going to ignore that. In the numerator, I'm going to keep x4 y cubed. Also in the denominator was this, but I'm actually going to move this to the numerator and make it a positive power. So this was x squared y to the negative 3 to the power of positive 2 now. And of course, all of this still has a negative 1. So let's simplify this a bit more. x4 y to the negative 3. Technically I could right away do some of the simplification here. This is just xy squared using like this and this. And then times, of course, x to the power of 4, y to the power of negative 6 to the power of negative 1. This is x to the power of y, y to the power of negative 4 to the power of negative 1. And here actually, you could move the y to the denominator and then flip, or actually here I'm going to do, oh no, I hate it when this happens. Give me a second. Alright, sorry. Again, I'm going to make this x to the power of negative 5, y to the power of 4. This is a negative power in the numerator, so I'm going to make it a positive power in the denominator. As in, like, the base is going to move to the denominator, and this is my answer. So, phew, that was quite the workout. And again, a lot of these questions are very similar. I don't think that, again, power rule, product times, you get what I mean. Multiply, and combine, multiply here. Again, square root is nothing but this to the power of half. So this is 25 to the power of half, which is 5. M to the power of negative 6 divided by 6 m to the power of 5, which is 5 over 6 m to the power of negative 11, which is actually, you don't even have to do it that way. You know you're looking for a positive exponent, so there's really no point to bringing the 5 up top, because it's going to be negative 5, and you already have a negative on the top. So again, m to the power of negative 6, this is the base, which has a negative exponent. I'm going to leave everything else in the numerator, and I'm actually just going to bring m to the 6 to the denominator, which makes it m to the positive 6, and this I'm going to combine as 5 over 6m to the 11. Again, we're using 100 x to the 6 divided, here I can move this entire thing to the numerator because it has a negative exponent in total. So this is just cube root of 100 x to the 6 times 10x to the 6, like this entire thing. This is to the power of 1, but because, again, at this base I moved to the numerator and changed the sign to a positive, but this is just cube root of 1000 x to the 12, which again, cube root is 1/3. So cube root of 1000 is 10. x to the power of 12 divided by 3 is x to the power of 4. Okay, these aren't that hard. What does this one look like? This one looks kind of interesting. What's the best method to go about doing this? I'm going to bring this to the new denominator. So I have 32x to the power of 5 squared. And this is just x to the power of negative 10, which I'm then going to move to the numerator as x to the power of positive 10. That's what I'm going to do. And obviously this is all to the power of 0.2. I'm actually going to try to simplify some more because I can. This is x to the power of 10 divided by 32 squared times x to the power of 10. So I'm just going to leave this as 32 squared x to the power of 10. And instead of 0.2, I'm going to write 1 over 5. X to the power of 10, x to the power of 10 is just x to the power of 0, which is 1. So this is 1 over 32 squared to the power of 1 over 5. And I'm going to flip these around, as I always want to do. I want to do the 1 over 5 first, and then do the squared. This is just 2 squared, so this answer is just 1 over 4. If you have a calculator, there's nothing wrong in doing 32 squared and taking the 5th root. You should get 4, but yeah, who wants to do that? Oh, this is easy. This is just, again, what is 1 over 10? So 10th root of 1024 is 2. 20 divided by 10 is 2. 9th root of 512 is also 2. 27 divided by 9 is 3. And again, 2 and 2 cross cancel. This is x to the power of negative 1, which is actually 1 over x. So that is that. Okay, I'm not going to do these questions. I've done enough practice with you guys. You should be able to. I don't think they're too difficult. You should be able to do them. Nothing looks too complicated here. Again, just product rule. This is 1 over 5. So the denominator really becomes 3x squared. X to the negative 3 to the power of 0.5. So you can combine these in a way that looks nicer. So this is just that. Okay, let's take a look at this thinking question. That's what I wanted to come to. If m equals that, to determine values for x and y so that m is all these different options. So first, let's simplify some things here. Looks like I have, first, I'm going to do this. So 16 to the power of 1 over 4 is 2. X to the power of 1 over 4 is, 8 times 1 over 4 is 2. Negative 4 times 1 over 4 is negative 1. I'm left in the denominator with 32x to the negative 2y to the 8. I'm going to cross cancel this to give me 1 over 16. This x to the power of negative 2, I'm actually going to move to the numerator, which gives me an x to the power of 2 plus 2, 4 in the numerator. And this is going to come to the denominator, y to the power of 9. So determine values for x and y so that m equals 1. So that's kind of difficult. So again, the idea here is that I want x to the power of 4 divided by 16y to the power of 9 to equal 1, right? That's m. This entire thing equals m. So the only way I see that being 1 is this y to the power of 9 has to disappear. So I'm just going to say y equals 1. So that goes away. Because 1 to the power of 9 is 1. And if I take x to the power of 2, I get 2 to the power of 4 divided by 16, and therefore I get 1. So now I want a value for which m is greater than 1. So this is actually now getting very simple because I can just say let y equals 1. Excuse me. X equals 3, for example. Now 3 to the power of 4 is going to be greater than 16, so that's greater than 1. For a fraction, I'm looking at, again, y equals 1, x equals 1. This is going to equal 1 over 16. And for here, m less than 0, you have to know that I'm looking for a negative number. And unfortunately, you'll note that x has an even power. So realistically, I can take x equals anything like 2, for example. And that still doesn't solve my problem because I still can't get the negative. The only way to get the negative is to introduce it in the y. And if my y is negative, negative 1 to the power 9 does give me a negative answer. So that's that. Whoa, what do you look at this? This is the volume and surface area of the cylinder are given by the formulas. Determine an expression in simplified form that represents the surface area to volume ratio for a cylinder. This is like exactly the same question from our assignment. Hashtag throwback. Okay, so surface area to volume ratio. So we're doing surface area divided by volume. We're looking for that ratio. 2 pi r plus 2 pi r squared divided by pi r squared h. I'm going to factor some things out. 2 pi r plus h divided by pi r squared h. Then I'm going to cross cancel some things, including the pi, one of the r's. So what I'm just left with is 2 times r plus h divided by r times h. And I don't know why this is in this unit, to be honest. So that's that. Easy peasy. This looks like fun. Again, trying these things was always a good idea. Let's take a look at this. This is 1, and again, I'm going to use the product rule here. So this is going to be x to the power of 2n plus 2 square root, because this is 1 plus 2n plus 1, which is 2n plus 2. And this is just x to the 3n divided by 3. And here I have x to the 2n plus 2 divided by 2 divided by x to the n. 2n plus 2 divided by 2 is just x to the n plus 1 divided by x to the n. Now I'm going to use quotient rule, n plus 1 minus n, which is just x to the power of 1. And hopefully solving for r, we can see that 3 over 4 pi equals r cubed. I just multiplied both sides by 3, divide both sides by 4, divide both sides by pi, and now I'm going to take the cube root of this. So I can either write r equals cube root of 3v over 4 pi, or I can write 3v over 4 pi to the power of 1 over 3. Both of those mean the cube root of it, so that's the same thing. Yeah, so that wasn't too bad. We're going to do one more lesson in this stretch, and we'll end it for today again, and hopefully we're feeling better about, by the end of next lesson, we should be master of the simplifying exponents art. Yeah, so I will talk to you later. Stay safe and healthy. Peace out.